Okay guys, sorry, had a bit of a disconnect there. All right, so we are back again for some probability. Back for some probability. So probability, guys, is the chance that something will happen, how likely it is that some event will occur. So again, probability is the chance that something will happen, how likely it is that some event will occur. All right. Probability of event A, as I had said or had explained, the probability of event A, if we are taking just an example here, and we're talking about, or we're trying to check, how do we write down the notation of probability of a event? Let's say the probability of the event, we are specifically referring to event A. The probability of event A happening, we simply denote that by P. P stands for probability, and then we say P in brackets A to denote that we are talking about the probability of event A. Right, so in brackets we always indicate that specific event whose probability we are checking. All right, so we use this notation. We denote the probability of something that we are looking at by saying P of that specific event. Okay, so sometimes we can measure probability with a what? With a number like a percentage. So if we look at this example specifically, if we're talking about 10% chance of rain, 10% chance of rain indicates a very low percent chance of rain. Okay, and guys, I don't know about you, but when I was young, whenever I would watch the weather forecast and they would talk about percentages or chances of rain, I usually used to think that they are talking about the volume or the quantity of rain that will actually emerge from the atmosphere and hit us here on the earth. That's what I used to always think. If it's 10%, it means there's less water coming from the atmosphere. But if it's like 90%, then I would think, it's gonna rain cats and dogs. I don't know about you guys, how you thought about it, but 10% chances of rain simply refers to the likelihood of it raining the next day. So it doesn't necessarily refer to the amount of water that will be coming from the sky, but it more fully refers to the chances of there being rain. So if they're saying there's 10% chance of rain, that just means that it is less likely that it will actually rain tomorrow, because the chances are closer to zero, which means it's more towards it not raining than it is towards it raining. Okay, so the lesser the chances of rain, it just means the rain may not occur. It may probably not rain, okay, if there's 10% chances of rain. Okay, so I hope that's clear for most of us, because this is very important. So that's why when we go back to probability, what is probability? It is the chance that something will happen, or how likely it is that some event will occur. Okay, so I hope that makes sense for most of you. So the probability of event A happening, like I said, we denote the probability of a specific event by saying P of that specific event. So how we measure it? We measure probability either by denoting it with a percentage, okay, as in this example, or we could use words, right, such as impossible, unlikely, possible. There are even chances, likely, certain. Okay, so I was just gonna indicate here that if we look at this example, for instance, it is unlikely to rain. it just means that it may probably not rain tomorrow. So there's a scale that we use, guys, in order to measure probability, right? Because the probability, right, is measured on the scale of 0 to 1. A scale of what? 0 to 1. It can never be less than 0. Probability can never be less than 0. It can never be more than 1. Probability is always between 0 and 1. Okay? So this is probability as a number. It's between 0 and 1. And so usually we can say that the probability of a specific event can be measured between 0 and 1. Okay. Probability of an event can be measured between 0 and 1. Okay. In other words, the probability can be greater than or equal to 0, but less than or equal to 1. All right. I hope that makes sense. So let's come here so that you guys can understand. So numbers, and obviously decimal number. So let's think about this a little bit clearly. 0 means it's impossible. All right. If I say the probability is 0, it means that particular thing is impossible. It's not happening. It's not going to happen. Okay? Not going to happen. No chance. So impossible, not happening, no chance at all. That is 0 exactly. Let's go midway. Okay, so between 0 and 1, let's say midway is 0, 5. What does that mean? It means that there's equal chances. You know when they say it's like 50-50, all right? 50-50, equal chances, okay? Then here at 1, this one, it's certain. You know when they say showcase, it's going to happen. It's happening for sure. Right? That is 1. When the probability is equal to 1, you must know that it is certainly happening. Okay? It's happening. Okay? Then think about this. If our probability is in this region, then that means it's more likely to happen. All right? But if our probability is in this region, then it means it is less likely to happen. Okay? So I hope we can appreciate this. At 0, not going to happen. impossible, not happening, no chance. Between 0 and 0.5 in this region, that particular thing is less likely to happen. At 0.5, it means there are equal chances. It could go either way. All right. Between 0.5 and 1, it is more likely to happen, for sure. More likely. It's more likely because it's closer to certain. All right. And then at 1, it's going to happen. It's certain. All right. It's certainly going to happen. So, there are things in life even like that we know for sure, like for instance, I'll ask someone, what are the chances that you will get level 7 in term 3? What are the chances? And I'm sure when you look at yourself, you think about yourself and you look at yourself and you can make a decision. Is the probability 0? Is it 0.5, or is it kind of like in between 0 and 0.5? Is it between 0.5 and 1? Or is it 1? Would you guys be able to answer me? What are the chances of getting level 7 in term 3 for mathematics? What is the probability of getting level 7? Is it 0? Is it in this region between 0 and 0.5? Is it 0.5? Is there equal chances that you could? Is it in this region, or is it certain? It's for sure, it's happening. It's certain that it's going to happen. Okay. Question is, would you be able to answer me? That's something I am very curious about. All right. So, guys, I hope we understand this whole idea or this notion of probability. So we measure probability, like I said, guys. Okay. In this fashion. It's at night. With the same scale, okay. Or we could represent our probability as a percentage. So we could represent the probability as a percentage. No chance means 0%, not happening, impossible, there's 0% chances. If we say there's 0% chances of rain, then it means it's not going to rain tomorrow. Okay. 50% chances of rain, that means there are equal chances of rain. If we say there's 100% chances of rain, it's certainly going to rain tomorrow, whether you like it or you don't. Okay. Yeah. So I want us to appreciate, guys, that we can represent or measure probability as a decimal number. All right. 0, 0.5, 1, the scale is between 0 and 1, if we're talking about decimal numbers, as a percentage, 0%, 50% chances, 100% chances. Okay, right? And then as a fraction, 0/1, a half, and of course we could say 2/2, depending on the situation, right? So I hope you guys can see, very important, and there are these values in between. All right, so if the value is between 0 and a half, we could explain in words what that probability actually means. All right, if it's 0%, 0/1, 0%, we can explain in words what that probability actually means. Okay, and if that value is between 0.5 and 1, if we're talking about decimals, 50% and 100% if we're talking about percentages, or a half and whatever number over the specific number, then basically we can explain in words what that probability means. So please take note, guys, of this scale, that there are various ways in which we can numerically showcase our probability and explain then in words what that particular value means. All right? Okay. Guys, I really hope we are in the same page. I really hope we are in the same beautiful page. So now, if we look at the specific definition of probability, and I mean the definition formally, because in theory we need to be able to do calculations and we need to be able to represent probability. Okay, so if, let's say, E is an event, okay, let's just say E is an event in a sample space. Then we say PE. And remember, what did we say P means? P stands for probability. E is the specific event that we are talking about. So in other words, the probability of the event E will be equal to NE over NS. So probability of event E is equal to NE. Now N, what does N stand for? So NE is simply the number of elements in event E. That's what NE stands for. And it is situated in the numerator of our fraction. What does NS stand for? It is the number of elements in the sample space. Okay. And as I had explained before, the probability of E we can expect will be between 0 and 1. It can never be less than 0. It can be never greater than 1. Okay, so this is very important. So what I'm saying now is, if E is an event in a particular sample space, we then say that the probability of event E is equal to the number of elements in event E and the number of elements in the sample space. You never know your probability. Probability. Right? Obviously, this is like the intro to grade 10 probability. It's important for grade 10, grade 11, and grade 12 because all grades need to know probability, which is very key. All right. So, like I said, E is an event in a particular sample space, right? Then we say the probability of that particular event E is equal to the number of elements in that particular event. Okay. That is actually doing it now. I believe my network is pulling a number right now. So let's quickly fix that. Okay, let me just let's look at an example for this, what we've just learned now. So let's just say A Okay, so I'm sure you guys all know what a dice is, because I'm sure some of you play or have played board games, snakes and ladders, all those games basically that require a use of a die. Okay, so let us say a dice is rolled. And what we want to check is what is the probability of getting a 3. A dice is rolled, and the question is what is the probability of getting a 3, right? Now, how many sides does a die possess, guys? Do you guys know how many sides does a die possess, right? So I'm sure you guys know that a die has how many faces? It has 6 faces. All right. There's the face where you have this dot, which represents 1. You have this one, which represents 2. You have this one, which represents 3. You have this one, which represents 4. You have this guy, which represents 5. Then you have this magical one, which so many people love because it means so many good things when you do get it and you are playing a game, especially if it's like snake and ladders and you want to get to the end very quick, because it gives you another chance to roll your dice again. So you have this one, this side, which is 6. So in total, we have 6 faces, guys. Okay, so let's not refer to them as sides, but faces. All right, we have 6 faces. All right, and each face contains a specific number. All right, so our sample space, and this is the important thing, our sample space, all right, has 1, 2, 3, 4, 5, and 6. So in total, the number of elements in the sample space is 6. Are you guys with me? So the sample space, guys, is simply all the sides, the faces with the numbers. There's how many of them? There's 1, 2, 3, 4, 5, 6. So the number of elements in the sample space, the total number of elements in the sample space is 6. Right? I hope we are together there. Now, remember, what did we ask? The question says a die is rolled. What is the probability of getting a 3? Right? Now, we want to find out what is the probability of getting a 3. So in other words, we want to find out what P3 is, the probability of event, what is the event we are talking about? Getting a 3. That's the event that we want. So the probability of getting 3, that is our event. But in order to get that event, we need the number of elements. Okay, so how many 3s are there for our faces? How many 3s are there? So this is 1, that's not 3. That's 2, that's not 3. That's 3. This is the only 3 we have. There's only 1 3. So the number of 3s that we have in our sample space is how many? Guys, how many 3s do we have? You tell me, how many 3s do we have from our die? Okay, thank you. We have 1. All right. So if we go back now to the probability formula that we have, we are going to say the probability of getting 3 is equal to the number of 3s that we have over the total number in our sample space. So in other words, remember, the number of 3s that we have is 1 over how many elements do we have in our sample space? We have 6. So the probability of getting 3 is 1 over 6. Are we together? I hope we are together here. Mam Timkulu is like holding the beautiful face there and is like, what? Right? Because I saw someone saying that's 50%. No, guys. Remember, what did we say is the definition remember, what did we say is the definition of probability? We said if E, let's say E is an event, okay, in a particular sample space, then we say the probability of that particular event is equal to the number of elements for that specific event over the number of elements in that particular sample space. Right. So in this situation now that we've just looked at, what did we say? We asked, if a die is rolled, what is the probability? Or in other words, what are the chances of me getting a 3 from the die that I've rolled? Okay. So the question then I need to ask myself is, okay, for this die, how many possibilities do I have in total? How many possibilities do I have in total? Maybe that will give you an idea as to what the sample space is. Sample space simply means the total possibilities that that particular object has. So in this situation, the total possibilities that we have, okay, is we've got a 1, we've got a 2, we've got a 3, 4, 5, and 6. So in total, how many possibilities do we have? We have 1, 2, 3, 4, 5, 6. That is what we refer to as our sample space. All right. Grade 10. Okay, grade 10. This is like the foundation for probability for grade 10. Okay. Then the total possibilities that we have so the number of threes that we have, okay, so remember I said the probability of a particular event. So in this case, what is the probability of getting a 3, the number 3? So we would say the probability of getting a number 3 is equal to the number of 3s that we have. So how many 3s do we have in our die? We only have 1 3. So here when I write n of 3, I'm saying the number of 3s that I have from the die. There are how many 3s? There's only 1 3, right? But how many possibilities do I have in my sample space? There are 6 of them. 1, 2, 3, 4, 5, 6. So my probability of getting a 3 is 1 out of 6 possibilities in total. Okay, so then the answer would be 1 over 6. Okay, and guys, remember I said we could write the answer as a fraction, or the same 1 over 6 can be expressed as a decimal. So remember, in order to write that as a decimal, guys, okay, I'm sure you guys have your calculator. You can say 1 divided by 6, and then you guys can let me know in the comment section what is 1 divided by 6. What answer do you guys get? Okay, all right, if we're gonna round it off to 2 decimal places, yes, definitely. All right, and I'm sure on the probability scale you guys can see where that is. Okay, it's closer to 0. Okay, So the chances of this happening it's less likely that they're going to happen. Okay, very slim. If we represent this as a percentage, we just say 1/6, we times it by 100 so that we can get the percentage, guys. Okay, so as a percentage, so hopefully we can see that as well, because these are the various ways you could write this answer. Could write it depending on the situation. They could say to you, represent your answer as a percentage. Are you with me? So then you would go ahead and you do that. Okay. So this was probability of getting a 3. Okay. Let's look at another question. Okay. What if we said the probability of getting a 5? Probability of getting a 5. All right. So once again, we go through the same exercise. Okay. We first write down. We're gonna now say P of what? Of 5 is equal to what? The number of 5s that we have over what? The number of elements in the sample space. All right. Then when we substitute, how many 5s do we have in our die? The number of 5s. How many 5s do we have, guys? Hopefully you can start seeing the trend now. Okay. Very good. I'm Tim Cool. It seems like I'm teaching you alone. Definitely 1. Then the number of elements in the sample space. So we are back at the die. The die has how many other possible options? Okay, before you get ahead of yourself, how many elements do we have in our sample space? Yes, there's 6 options. You see? So still, our answer, okay, we have 1/6. Okay. Okay. And if I was then to ask you, which you can see it's the same answer as that one, right? You could represent that answer as a decimal. You could represent that answer as a percentage. Okay. So like I said again, the definition for probability is the probability of any event. So in this case, we are saying the probability of getting a 5. What is the event? The event is getting a 5. That is the event. And we are looking at a 6 fair die that we have. We know almost a die has 1, 2, 3, 4, 5, 6 possible options that we can get when we roll it. So this is our sample space. 1, 2, 3, 4, 5, 6. We have 6 total possible outcomes, which represents our sample space. All right. So these are the individual options. How many are there in total? There are. How many options do we have in our sample space? We have 6 of them. That's the total possible possibilities that we have. Then how many 5s do we have from our die? We only have 1 5. The number of what? The number of 5s. So the probability of getting a 5 is the number of 5s over the total possible outcomes, which is 6. So basically that's why we say the answer is 1/6. Let's investigate another question. The probability, still we're talking about a die, the probability of getting an even number. The probability of getting an even number from our die. The probability of getting an even number. So what is the event? The event is getting an even number. The probability of getting an even number. So now we need to go back and ask ourselves, do we know what an even number is? Do we know what an even number is? That is the $1 million question. And on our die, how many even numbers do I have? So the probability of getting an even number. So I'm just gonna say P even number, right? That means the number of even numbers over the sample space. Yes, Mamtimkulu, very good. So from my die, if I look at my options, how many of the options in my sample space are actually even numbers? Can you guys tell me? Very good, Mamtimkulu. Mamtimkulu is like on the money there. The even numbers, very good. Mamtimkulu first told us that an even number is a number that can be divided by 2 without leaving a remainder, which is very good. So if you didn't know what even numbers are, then it would be very difficult to identify from our die the even number options. So I'm sure you guys can see the even numbers. If we roll a 2, that's an even number. If we roll a 4, that's an even number. If we roll a 6, there's an even number. How many options do we have? We have 1, 2, 3. So that means the number of even numbers that we have is what? Is 3. Okay. 3 out of what? How many options do we have in total from our die? 3 out of what? What is in our sample space? Very good, Mam Timko. And thank you so much. So there are 6 total possible outcomes. So that means 3 over 6. And 3 over 6 simplified is equal to a half. It becomes very important for us to simplify our answers if that is possible, right? And of course, we can write this answer as a decimal. We can write it as a percentage. Okay. Okay. So that means when you roll your die, there are 50% chances that you will get an even number. Alright? There's equal chances of getting an even number. Alright? Okay. Are we good? Can I move on to the next question? Are we at least getting the hang of this? So all in all, at the foundation of being able to write down the probability of something is understanding the definition. Grade 10, guys, grade 10. But if you are in grade 11 and you are here, you are 100% in the right place, because this is the foundation that you need. Even as you are in grade 11, you need to understand the foundational concepts that have to do with probability. So in the numerator, it's always the like I said, this is grade 10 and 11, guys. If you are in grade 11, you are good being here, because this is the foundation you need. All right. So number of even numbers from our die, there's 3, and then the total possible outcomes we have from the die is 6, and 3 over 6 can be written as a half. which is very good. Okay, let's look at another question. Probability of getting a prime number. Probability of getting a prime number. Okay, remember we are still dealing with the die here. Okay, and these are sub questions we are answering. A die is rolled. What is the probability of getting a prime number? So what is our event? Our event is getting a prime number. Getting a prime number. So I'm just going to say probability of prime number. So I need to start here. What is, first and foremost, what is a prime number? Okay, you need to understand that first. And after understanding that, then I need to ask myself, how many prime numbers exist in my die? Okay, what is a prime number? Do we all know what a prime number is? Can someone rescue the situation? What is a prime number? Okay, very good, Mom Tim Cool. So prime numbers are numbers that are divisible by 1 and that particular number itself. Very good. So in other words, numbers that have two factors, 1 and itself. Right? Okay, very good. Things flowing there. Yeah. So the probability of a prime number. Let's go and identify the prime numbers we have here. Is 1 a prime number from our die? No, it isn't. 2, yes. 3, indeed. 4, no. 5, indeed. 6, no. So, as Mam Tim Kule said in the comment section, we have 2, 3, and 5. Okay. From the dice. Because in the die itself, we only have those 3 options, 2, 3, and 5. Okay. Though 7 is a prime number, it is not a prime number that exists for the die. Okay. So that means the number of prime numbers we have for the die is 3. That is the number of prime numbers we have. Then what is the total number of options that we have for our die? We still have 1, 2, 3, 4, 5, 6. So we still have a sample space of 6. Okay. So then now we can write down the probability, because we have our numerator and our denominator. So probability of prime number, of getting a prime number, is n of prime over n of the s, which is sample space. So that is 3 over 6, which we can simplify as half. Okay. And then of course, if they say to us we meant to represent our answer as a percentage, that we can do. If we need to represent our answer as a decimal number, that we can do, no problem. Okay. So are we getting the idea of this definition of probability? Okay. Okay, I'm just gonna do a little bit. That's fine. A little bit is okay. So a letter is drawn from the word beginning. Okay, so this is we are told here a letter is drawn. In other words, it's like we are taking a letter from this word. So a letter is drawn from the word beginning. Then we are asked, question number 1, what is the probability of drawing or taking, it's like we are taking, of drawing the letter E? What is the probability of drawing, or in other words, of taking from this word the letter E? What is the probability of drawing the letter E? In other words, of taking the letter E. Okay, so the probability of E, in other words. Okay, because the event in the situation is drawing the letter E. So I'm just gonna say the probability of E. So in order to be able to calculate the probability, we need to first find out what is the number of E's that we have in the letter. How many E's do we have, guys? The number of E's. How many E's do we have? From the word beginning. Okay, Tabata 7 says 1 Mamtikulu Lili. Yes, true, guys. The number of E's that we have is 1. 1. 1.